Hello, class. Before we go any farther in the unit, we want to talk about an important thing, and that topic is what is a line? What exactly makes up a line in algebra? So, a line in algebra is made of a collection of an infinite amount of points that satisfy one similar equation or situation. So, when you look at a line, it looks like one object. But if you kind of zoomed in on a line, there's actually an infinite amount of coordinate points that make up that line. So here's an example for you. Right now, let's say you have 4 gallons of gas in your tank. So right now, if we're talking about the x-axis for time, that'd be 0. We're at 0 hours. And right now we're saying we have 4 gallons of gas. So we'll just say we have 4 gallons of gas right now. That's where we're at. And every hour that we continue to drive, we're going to lose 2 gallons. We're going to use 2 gallons. So you might be saying, well, after 1 hour, we should be at 2. Right. So after 1 hour of driving, we're down to 2 gallons. After 2 hours of driving, we should have 0 gallons of gas. Now, lines actually continue in both directions infinitely. So for this situation, we could actually do what's called extrapolate backwards. We could see what would happen backwards. So right now we said we had 4 hours. We had 4 gallons of gas. If we went back an hour, so if we were continuing to drive this whole time and we went back an hour, we could see how much gas we had an hour ago. And continuing the trend backwards, if I know I'm using 2 gallons of gas every hour, last hour I should have had 6 gallons of gas. And the hour before that, I should have gone up to 8 hours. And the hour before that, 8 gallons. And the hour before that, 10 gallons. Now, these aren't the only points that make up the situation. Because if you think about it, I'm driving constantly. I'm not just skipping ahead an hour. I actually have minutes in between here. So let's go to 30 minutes. If I look at 30 minutes from now, how much gas will I have? Well, I know that if I'm driving and I'm using 2 gallons every hour, every half an hour I should be using 1 gallon, right? So if I go to 30 minutes from now, I should use 1 gallon. So there should be a point right in the middle there. And I know every 30 minutes I'm using 1 gallon. So what happens if I have 15 minutes? What if I drive for 15 minutes from now? How much gas am I going to have? Well, 15 minutes from now would be half of the 30 minutes, and that was 1 gallon. So half of 1 gallon is half of a gallon, right? So if I'm at 15 minutes, I'm going to have another coordinate point right here. And then, well, smaller than that, what's half of 15 minutes? Well, we could do 7.5 minutes. So 7.5 minutes would be a quarter of a tank of gas. So you'll see that I can make this distance smaller and smaller and smaller. There's an infinite amount of coordinate points in between our points that we plot. And if I do that enough times, what happens is we have a line form, because all of those coordinate points in between satisfied the situation. They work for the situation because they follow the trend. I'm using the constant amount of gas, the same amount of gas every time. And eventually what we do is we just darken it in and say, well, there are infinite amounts of lines in between. So we just connect the dots. So in algebra, the situation that we're talking about, that we're fulfilling, that all the points are working for, is most of the time an equation. So in that situation, we could create the equation for that situation. We knew we had 4 gallons of gas, and what was happening in the situation was we were taking away gas. We were taking away 2 gallons, and we took away 2 gallons however many times there were hours, right? So it was a change, it was varying. So the amount was varying, so we use a variable to show how many hours we have to take away the gas. And that would equal our total. So this is the equation, and every single one of those points that we created on the graph on the previous page will work in this situation. Let's just take one of these points as an example. Let's take 1, 2 as an example. So we said that that should be on our line. And if we take 1, 2 as a coordinate point, we know 1, 2 is made of an x value and a y value. That will work in this situation. It will satisfy our equation. So if I just plug it in quickly and do the math here, 4 minus 2 is 2, and 2 equals 2. So to sum up what we just went over, we answered the question, what is a line? And a line is just a collection of all the possible coordinate points that satisfy a situation. And more specifically, when we're talking about algebra, it's all of the coordinate points that work in the equation that represent that line.